Hi and welcome back to class of Product Development and Entrepreneurship. I am Hitesh Raiyani, Assistant Professor at LJ Institute of Engineering and Technology. This is lecture 17, a different manufacturing process, different additive manufacturing process. The learning outcomes of these lectures is to learn the different additive manufacturing process like stereolithography, fused deposition molding, and the selective laser sintering. So let's we start the additive manufacturing methods. So before we start the additives manufacturing methods, first I call back the classifications of layer manufacturing process. As we all know, the classifications of this manufacturing process is according to the material use and the principal use for the creating of layers. So according to that, there are the powder, liquid and solid materials, for powder materials there are the sintering process, and this sintering process there are the selective laser sintering. So in these lectures we learn the selective laser sintering process, how the component is manufactured according to the selective laser sintering process. And if you look at the liquid materials classifications according to the liquid materials, there are two principles: extrusion process and liquid polymerizations. So here if you think that in liquid polymerizations there are two types of principle use, the two types of techniques used. First is the photomasking process and second is the laser process. So in laser process there are the stereolithography. So in these lectures we also learn the stereolithography, which is the process based on the principle of liquid polymerizations, and the laser is used to make the polymerization. And if you look at the solid materials, there are laminated process and laminated process. There are two types of process. There are bonding of sheet with adhesive materials and bonding of sheet with the light. There are bonding of sheets with adhesive. There are the laminate object manufacturings, and bonding of sheets with light. There are foil polymerizations. So here in this lectures we first learned the stereolithography, and we learned the fused deposition molding, and we learned the selective laser sintering. So let's we start the first additive manufacturing system, that is stereolithography. So as I told in previous lectures, the stereolithography process is the first additive manufacturing process which is used to make the component by the additive of materials. So these are the first additive manufacturing systems, and in these systems format used for the data exchange, this format is later considered as the standard format for the industrial purpose. So nowadays STL format is considered as a standard format to convert or to transfer the data. So data exchange format for the additive manufacturing process is considered as a STL format as a standard. So if you look at the stereolithography setups, here the liquid polymers is contained in a containers, and here the platforms is shown. In platforms is used to make the components, and this platform is attached to this lead screw elevations. So according to this lead screw mechanisms, the platform can move up and move down with respect to z axis, and laser is used in this process, and laser's movement can be done in x-axis and y-axis. So xy positioning system is here to traveling the laser in x directions and y directions. So sorry. So here the first layer on the platform is done by the lowering the platforms by the first layer of the thickness. So whatever the first layer of the thickness, platform is make down according to this lead screw mechanisms, and whatever the thickness of first layers, here the liquid polymerizations, liquid polymer is contents, and when the laser is fed on this liquid polymer according to the cross sections of cross sectional area of this first layer, the polymerization process is done and the first layer of this component is generated or manufactured. So once the first layer is manufacturing, as we know that this is the layer by layer manufacturing process. So after that we have to make the second layer of this process. No? So whatever the layer thickness of second layers, layer thickness of second layer, we have to move these platforms. We have to move these platforms according to the second layer thickness by this lead screw mechanisms. So after that there are the second layer is generated, and once the second layer is manufactured, there are the lowering the platforms by the screw lead screw mechanisms according to the third layer of the thickness. So this way the layer by layer manufacturing of cross sections is done. And so in this process here you can see that so many layers are manufactured, and according to that the component is built here, and after the manufacturing of full components, this platform is made up and the component is removed. So these are the stereolithography process, and the principle used to generate the or manufacturing the component is the polymerization process, and the liquid polymer is used as a material. So next process of additive manufacturing process is the fused deposition molding. So in fused deposition moldings, the mold material spools and support material spool is used, and here the filament is transmit to the extrusion nozzle. Here you can see that this is the extrusion nozzles, and here the platform fabrications platform is made, and this platform is moved in up and down directions by here as here shown. And here there are the two nozzles. First is for the materials which is used for the components, and the second is the materials for the supportings of that particular layer. So here you can see that the filament is transmitted to the extrusion nozzles, and the temperature of extrusion nozzles can melt the filament, and then by the extrusion process the material is additive to make the layer of cross sections. So here you can say that the gray colors is the components, and here the saffron color is the supporting material. So as we saw that layer 1 and 2, so 3, 4, 5. So after the layer 5, if we have to make the 6th layer, we have to add the supporting material. So here to generate the next layer, so we have to add the supporting material. So here the two materials is supplied. First is for the component, and second is for the supporting material. So in this process, the after the layer by layer manufacturing process is done, and after the completions of final components, the material is removed from the platforms and the supporting material is removed to get the final component. So these are the fused deposition molding process. And the next is the selective laser sintering. So in this selective laser sintering process, the laser is used to sintering the powder particles. So here the material is used as a powder. So here if you see the setup of selective laser sintering, there are the two piston cylinder system. First is for the powder deliver pistons, and second is the fabrication piston. So this first piston cylinder is for the supplying of powders, and this second piston cylinder system is for the fabrications of the component. And here a laser is used to sintering the powder particles. So here you can see that the powder delivery system, there are the pistons is upward according to the layer thickness. So once the layer thickness is decided, or slicings of component is done according to the cross sectional thickness, the first powder deliver systems is move up, and according to that the first fabrication piston is set up, and here the powder is compressed, and here there are the hot rollers. So it will hit the powder particles below, and the temperature of this roller is slightly lower than the melting of the powder particle. So after that this powder is supplied, this powder layer is supplied to the fabrication piston. So here the powder is powder layer is made by the supplying of powder delivery systems, and after that the laser is transmitted according to the cross sectional area requirement. So whatever the area which is covered by the laser, that can be sintering, because the temperature of these powder particles is slightly lower than the melting point. So the slightly we need the lesser intensity of the laser to sintering the particles. So according to the cross sectional area requirement, the laser transmitted on the powder particles. So powder particles sintering to each other, and the layer of cross section is generated. Once the first layer is generated, this fabrication pistons is down by the layer thickness, and this powder systems is up by the layer of thickness, and the material is transmit to the fabrication piston. Again the laser is transmitted according to the second layer of the cross sectional, and the second layer of cross section is generated. So in this way the powder system deliver up by the layer thickness, and fabrication systems is down by the layer thickness, and the layer by layer of cross sections of component is manufactured by the sintering of powder particles, and for sintering of powder particles the laser is used. So in selective laser sintering, the laser is used to sintering the powder particles, and here the material is used to make the component is the powder. So if you look at selective laser sintering, here I shows the raw materials of FeCu powder mixture, and after sinterings you can see here, after sinterings the sintering particles of the powder, so that can be built solid, and this is the principle used to make the 3D components according to the selective laser sintering. Here I shows some examples fabricated by the additive manufacturing process. Here you can see the examples. So in these lectures we learn the additive manufacturing systems like selective laser sintering, fuse deposition molding, and stereolithography. In our next lectures we learn the virtual reality. Thank you.